Hi everyone, welcome. Thank you to GMAT Club for hosting this event, and thanks to all of you for joining me live. For those of you who don't know me yet, my name is Avi Gutman. I've spent 9 years with Manhattan Prep, and now I run quantreasoning.com. At Quant Reasoning, we focus not on picking the right answer to a practice question, but instead we focus on what we can learn from that question and how to improve our reasoning from that question. I have a very exciting hour planned for you today. We're going to use only official GMAT questions. We'll see word problems, we'll see algebra, we'll see divisibility and remainders, we'll see data sufficiency. The difficulty level will increase as we get through the hour. But what all the questions have in common is they are most easily solved using number line reasoning. Now, I'm sure all of you have heard of number lines, and I'm sure you've all heard of reasoning, but how many of you have heard of number line reasoning? Give me a yes in the comments if you have, and a no if you haven't. So at its most fundamental level, number line reasoning is thinking about things like this. So if we know where x is on a number line, we're looking for x plus 3. Where would you expect to find x plus 3? To the left of x, to the right of x? How far to the left or right? Plus 3 literally means 3 units to the right on the number line. So that shouldn't be excessively difficult. Let's look at another example. There's x minus 2 on the number line. Where would you find x minus 5? Again, would that be to the left, to the right? How far to the left or right? Well, x minus 5 is an extra 3 units to the left, so there it is. Now things tend to get a little bit more complicated when we introduce multiplication. So, if 2x is right there, and we'd like to find 6x, where would we find 6x? Would it be to the right of 2x, to the left of 2x? How far to the right or left? And the truth is that with multiplication, the answer is it depends. Specifically, it depends on the position of 0. You see, if I tell you now that 0 sits right there, well, now we wouldn't think that 6x would be to the right of 2x. Whatever the distance is between 0 and 2x, you'd have to triple that, because 6x is triple 2x. So whatever that distance is, you'd copy it, and you'd paste it 2 more times to the left, and there's 6x. All right, so number line reasoning starts as something very simple with just addition and subtraction, but then it starts getting a little bit more complicated when we introduce multiplication or division. Now, verbally, we would say 6x is 3 times as far from 0 as 2x is, because again, 6x is triple 2x. And it's on the same side of 0. So whichever side of 0 2x was, 6x will also be on that side of 0. Let's look at another example. So if I tell you that x lives right there on the number line, where would we find half of x? Again, would it be to the left of x, to the right of x? How far to the left or right? And yet again, we realize that it depends. It depends on where is 0. So if I tell you now that 0 is right here, you'd say half of x will be the midpoint between 0 and x. So whatever that distance is, you'd cut it in half, and that's where you'd find half x. Okay, so the position of 0 is critically important when you're talking about multiplication or division on the number line, and not important at all when you're talking about addition or subtraction. Those first two questions, we didn't care where 0 was. So we could say verbally that half x is half as far from 0 as x is, and of course they'll be on the same side of 0. Final example, and then we'll look at some official GMAT questions. So if I tell you that negative 2x sits right there in the number line, so negative 2x is there, where would you find 6x? That's positive 6x. So we know where negative 2x is. We're searching for 6x. Where would you find that? To the right, to the left? Where is 6x? Yet again, the position of 0 is really important. Without that, we can't make any inferences whatsoever. So if I tell you that 0 is here, some of you will say that's impossible, because how could negative 2x be to the right of 0? But remember, we don't know anything about the value of x itself, right? X could be negative. For example, if x is negative 1, then negative 2x would be positive 2. So it is possible that negative 2x is positive as long as x is negative. And where would 6x be? 6x would be triple the distance from 0 that negative 2x was, because there's a factor of 3 that we'd be multiplying by, but would be on the opposite side of 0. So whatever that distance is, we're going to paste that 3 times on the other side of 0, and there's 6x. All right, feel free to give me questions in the comments. I do have an eye on them, and I do want to make this interactive. Also, if you're enjoying it so far, a thumbs up goes a long way for these kinds of videos, so that would be appreciated. We would say 6x is 3 times as far from 0 as negative 2x is, but on the opposite side of 0. So finally, here's an official GMAT question. It's an algebra question, as you can see. And I'm going to give you 2 minutes to try it on your own first, then we'll come back and talk about it. So I'm going to put a 2-minute timer on the screen. There we go. Good luck. Okay, so that was 2 minutes, and I am seeing some good answers in the comments. But I'll remind you that it's not about picking the right answer. It's about learning from the question and improving our reasoning from the question. So I find that for a question like this, it's really important to break it into small chunks. And I would start with just this chunk. So I'm told that a multiplied by a plus 2 is 24. And so I would ask myself, well, if I know where a is on the number line, where would I find a plus 2? Would a plus 2 be to the right of a or to the left of a, and how far to the right or left? We can actually draw a number line, and we can say If a is here, a plus 2 will be here, 2 units to the right. Now I'm told that this product, a times a plus 2, is 24. And I also see on my number line that a and a plus 2 are 2 apart, 2 away from each other. I was not told that a is an integer, but given that this is a GMAT question, it's almost guaranteed that a is an integer. So now I'm thinking, well, what are 2 numbers on the number line that are 2 apart, 2 away from each other, whose product is 24? And I can just think of factors of 24, or alternatively, I can think of numbers on the number line that are 2 apart. 1 times 3, no, that's too small. 2 times 4, is that 24? No. 3 times 5, no. Oh, 4 times 6. So it doesn't take a lot of trial and error to figure it out, that the values of a and a plus 2 could be 4 and 6. So I would write down 4 and 6 below them. Now, there's only one thing when you're using number line reasoning to do this kind of thing, to look up multiplication. There's only one thing that you have to remember, and that is the mirror image. You see, if 4 times 6 is 24, negative 4 times negative 6 would also be 24. So taking the other side of 0, the mirror image of your factors, will also give you a possible solution. So I have 4 and 6. I also have negative 6 and negative 4. And if you're not sure about the order, well, a number line always increases going from left to right. So it wouldn't make any sense to have negative 4 on the left and negative 6 on the right. It only makes sense this way. And then I'd say, okay, a is either 4 or negative 6. And I think it's important to make that inference at that stage. So there's no rush to read the whole question. I think that's a big mistake a lot of people make, is they try to read all the way to the question mark and then they start working. Why? Right? Stop there, make the inference, find out that a is either 4 or negative 6, and then read the next little part. The next little part says exactly the same thing, but about b. So if my inference about a was that it's either 4 or negative 6, I'll have the same inference about b. It's either 4 or negative 6. And then I read the next little part, which tells me that a and b are not the same number. Well, if they're not the same number, and each of them is either 4 or negative 6, then one of them must be 4 and the other must be negative 6. I don't know which one is which, but one of them is 4 and the other is negative 6. So then I keep reading. What are they asking? Oh, they want the sum. Well, I don't know which one is which, but if all they want is the sum, then it doesn't matter which one is which. 4 plus negative 6 is negative 2. So by the time I get to the question mark, I pretty much already have the answer. And that's a strategy that works really well across the board on the GMAT, including word problems, etc. We'll see that again later today. So let's move on and see how the difficulty level can increase. And again, I'll give you 2 minutes to work on this. Okay, we're back. So this is a word problem, and we're talking about Mark and Anne. And the first thing that I kind of notice here is that Mark sold 10 boxes less than N, and I'm thinking, well, but what's N? I don't know anything about N. So N is some random number. I do think we can tell that N is a positive integer because the number of boxes that a person could sell has to be a positive integer as well, or at least 0, I guess. So N must be at least 10. And you could draw a number line and you could say, if N is right there on the number line, where would Mark be? Where is Mark on this number line if he sold 10 boxes less than N? And I think it's important to do that work when you're here at the word and. So before you keep reading past the word and, pause, draw a number line, and say, well, if Mark is 10 boxes less than N, Mark must be right here, 10 to the left of N. Then you keep reading, probably pause again at the comma, and ask yourself, oh, excuse me, my bad. Pause here at the period, and ask yourself, where is Anne if Anne sold 2 boxes less than N? Where could Anne be? Well, Anne must be 2 to the left of N. Then they say something that's really surprising, I think. They say that they each sold at least 1 box of cookies, but together they sold less than N boxes. So is it just me, or is any of you also surprised by the fact that although Anne almost sold N boxes, Anne was just 2 below N. It was really close to N. Just 2 below. But Anne plus Mark, they both together still sold fewer than N? What does that mean for Mark? If you're adding Mark's boxes onto Anne's boxes, and again, Anne was just 2 below N, and then you add Mark to Anne, and it's still below N, then Mark must have only sold 1 box. We know he sold at least 1 box, they told us that. But he must have sold exactly 1, because if Mark had sold more than 1 box, we'd already be at N, and they told us that we're not at N. So this is what I mean when I say number line reasoning. I'm not really doing any math. I'm not doing any algebra, that's for sure, but I'm thinking about the situation deeply, right? And I'm looking at the number line and I'm saying, well, again, if Anne is already so close to N on her own, and now we're adding another positive integer to Anne and still not reaching N, then that positive integer has to be 1. And if Mark over here is 1, then what does that mean for N? N is 10 units to the right of Mark. So if Mark is 1, N must be 11. Okay. The difficulty level is definitely about to increase, so brace yourselves. And again, here's 2 minutes on the timer. All right. So data sufficiency. We have these four numbers on the number line. We don't know. I know they look like they're equidistant, like it's an evenly spaced set, but we can't take that for granted. It just looks that way. What we can take for granted is the relative order. So for sure, Q is on the left, followed by R, followed by S, followed by T. That's for sure. Now, statement 1 tells us that Q is negative S. So I can just go ahead and put that in there. Q and negative S is the same thing. Now, we have S already on the number line. And now we also have negative S on the number line. The one thing we can say about S and negative S is that they're mirror images of one another on the number line. In other words, 0 has to be at the midpoint between negative S and S. 0 has to be exactly in the center between those 2 points. So 0 is right there. Now again, I don't know that R is right there in the center, but I can tell for sure that R is somewhere inside that range. R has to be somewhere between Q and S because that's how they gave it to us in the diagram. And if R has to be somewhere inside that range between negative S and S, and we know that 0 is in the center of that range, are we able to answer the question? They wanted to know whether or not R is closest to 0. Again, if R is in the range and 0 is in the center of that range, and there are no other letters in there, yes, R is closest to 0. So statement 1 is sufficient on its own, and we can eliminate answer choices B, C, E. So moving on to statement 2. Statement 2 tells us that that negative T is to the left of Q. So I would move those a little bit to the right and insert negative T right there to the left of Q. So similar to what we did in the previous statement, this time we have negative T and T on the number line. So that tells me that 0 is at the midpoint between negative T and T. So 0 is in the midpoint. The problem is Q, R, and S could move around. They could be anywhere. So the 0 is going to stay put at that midpoint between negative T and T. But you can see here, let me show you that again. So Q, R, and S, I can play around with them as much as I want as long as I maintain their relative order. And we can see that in this case, Q is closest to 0. In this case, R was closest to 0. So is R closest to 0? I don't know, and that's why it's insufficient. So correct answer here is A. All right, as promised, the difficulty level will continue to increase throughout the hour. Let's look at the next question, this time with remainders. All right, that was 2 minutes. So in this word problem, I again would recommend not reading all the way to the question mark and instead stopping there at that first period and thinking about that for a bit. So there's some integer n. By the way, this question is from the Advanced Official Guide. We have some integer n, it was divided by 17, and we got a quotient. So for those of you who don't know what a quotient is, it's essentially how many times 17 goes into n. Okay, so just as another example, 30 divided by 7 would give a quotient of 4, because 7 goes into 30 4 times, and there'd be a remainder of 2. So that's what quotient means. And when they divided n by 17, they got a quotient of x. So that means that 17 goes into n x times. That means that 17x, so if we multiply 17 times x, that would get us pretty close to n. But there is a remainder, so it wouldn't get us quite all the way to n. So if you were to draw a number line and put n on that number line, where would you put 17x? Would 17x be to the left of n, to the right of n, equal to n? If it's to the left, how far to the left? Think about that. Again, we know 17 goes into n x times, but there's a remainder. So that means that 17x is to the left of n. How far to the left? This far. We can draw that on a number line. Here's 17x. It's exactly 5 units to the left of n. So that's the inference that we can make from that first sentence. This is pure number line reasoning. It's beautiful. Let's read the second part. When n is divided by 23, the quotient is y. And there's also a remainder here. So what is this saying? That 23 goes into n y times. So 23 times y, 23 multiplied by y would get you kind of almost to n, but not quite. It would still be 14 units to the left of n. So that would be the number line reasoning inference that we would make there. And once you have all of this on your number line, I think the almost obvious inference you'd probably make is that that left side must be a distance of 9, because 9 plus 5 is 14. You can see it visually very clearly there. And once you have all of that on your paper, you keep reading the rest of the question, which is asking, I think it was just asking which of the following is true. And then you see the answer choices, and you look at your picture and you say, well, 17x minus 23y is 9. That was the inference that I made before I even knew what they were asking. So the answer is B. Again, no algebra, no math really, just reasoning. Right? So if you loved it, I would love a thumbs up, and let's keep going. So that was 2 minutes. Um, I want to address a couple of questions that I got in the comments, and then we'll come back to this question. So one question was, can we use this kind of number line reasoning approach to every single remainder question on the GMAT? And the answer is no. There are a lot of creative types of questions that the GMAT can ask about remainders. In some, we'll be able to use this approach. In some, we won't, just because of the nature of the question. But what I can promise you is that translating the type of language that we saw in that question, where they said n divided by 17 gives a quotient of x and a remainder of 5, translating that onto a number line will absolutely deepen your understanding of divisibility and remainders. And that deeper understanding will serve you very well on, yes, every remainder question. So maybe the number line itself won't, but that number line drives that deeper level of understanding of what remainders really are, and that will help you on every remainder question. Another question I saw was, how can you tell when you can use number line reasoning on a question? And you might not like the answer, but the only way to really get good at identifying when I can and should use number line reasoning is when you're practicing at home, when you're seeing official GMAT questions at home, try to use a number line on every single one, and then you'll see on some of them, wow, that was amazing, and on others, oh, the number line wasn't helpful here. That's the only way, because then with practice and with experience, you're going to get better at knowing really quickly, should I draw a number line here or shouldn't I? And the other thing that's going to happen when you practice a lot of number line reasoning is you'll realize I don't actually have to draw the number line anymore. I can just kind of see it in my head. So that will happen eventually as well with enough practice. But for now, in the beginning, I would say just attempt to use number line reasoning on every single question. And I think it's really important when you're practicing at home to not use a timer. Because when you're using a timer, that doesn't encourage trying to be creative and trying to use different approaches and trying to reason. Right? When I see that timer ticking, my mind goes into fight or flight mode. And I get anxious, and I'm definitely not thinking outside of the box. So I definitely would recommend not using the timer when you're trying new questions at home, so that you can experiment and try different approaches. So I think that addresses the couple of questions that I saw there. Let's go back to the temperature question that we were just looking at. And what they're testing in this question is really number line reasoning. A lot of people don't realize that, but if you think about what happens to a set of numbers on the number line, let's just draw quickly here a number line with a set of numbers. Here's some numbers. So I drew some tick marks on the number line. If I add 5 to every one of those tick marks, what will that do to the distances among the tick marks? So I'm thinking about this distance, that distance, and that's it, I guess. There's 3 distances on this in this set. What would happen to those gaps, to those distances among the tick marks, if we add 5 to every tick mark? And the answer is nothing. The tick marks will just move up the number line by 5 units, but the gaps among them won't change. So additive changes, meaning addition or subtraction to a set of numbers, won't impact the distances among those numbers. On the other hand, multiplication or division would. So let's see what that would look like. I'm going to use actual numbers here. Say we have -2, 3, and 10. So that's our set of numbers. The gaps, the distances among them, we've got a distance of 5 here and a distance of 7 there. If you double every one of the numbers, so you'd have -4, 6, 20, what would that do to the gaps among the tick marks? Let's see. I'll draw it up here. So now we have negative 4, 6, and 20. What happened to the gaps? This gap is now 10. This gap is now 14. So our gaps were 5 and 7. Now they're 10 and 14. What happened to the gaps? They doubled. So by doubling the numbers in the set, we doubled the gaps among the numbers in the set. We doubled the size of the gaps. So multiplicative changes to a set will impact the distances among the numbers within that set. And that's really the concept that the GMAT is trying to test in this question. So going back to the original question, we're talking about, it looks like a formula question, right? You've got your formula for converting from Celsius to Fahrenheit. But when you look closely at the formula, you see two things. You see subtraction, and you see multiplication, right? Multiplying by 5/9. And you'll notice that the question is asking about a difference between two data points on a number line. And you have to ask yourself, the minus 32, how will that impact the distance between 2 points on the number line? As we just discovered, addition and subtraction doesn't impact the distance between the points. It moves the points up or down the number line, but it doesn't actually impact the distance between them. On the other hand, when you ask yourself, what impact will a 5/9 have on the distance between the two data points? Well, it would multiply that distance by 5/9, as we just discovered. So if we knew how far apart the two data points were originally, we can infer how far apart they are now, because you just multiply by 5/9. And that's exactly what statement 1 gives us. It gives us the difference between the temperatures in Fahrenheit. And so we can tell that in Celsius, you would just multiply that distance by 5/9. So not that we actually have to do this on the GMAT, but if you're curious, the answer would be 5/9 of 45. So we reduce the 9 and the 45, and so the answer is 25. The difference between the temperatures in Celsius would be 25. And I can tell that by just knowing the difference between the temperatures in Fahrenheit, again, because we know that the minus 32 won't have any impact, and the 5/9 will impact the distance by a factor of 5/9. Okay? Now, statement 2 on its own, well, it just gives us one of the temperatures. We don't know anything about the other, so of course there's no way for us to infer the difference between them. Okay, so again, as usual, I'll keep an eye on the comments, keep those questions coming. I have one more question prepared for you here, and then I'll use the rest of our time to answer any of your questions. Since you're attending live, I think it's only right. So here comes the final official GMAT question of the day. 2 minutes. Good luck. Oh, that was 2 minutes. Could you tell that this question was testing the same concept as the formula temperature question? Both salaries of both people grew by the same percent. Now, percent change, is that something additive or something multiplicative? Is it more similar to addition and subtraction when you do a percent change, or was it more similar to multiplication? I'm thinking, just as an example, a 20% change, 20% increase would mean multiplying by 1.2. So it is something multiplicative. And I'm also thinking, well, as an example, if both salaries were doubled, what would happen to the difference between the salaries? That would also double. That's really the concept that we discovered a few minutes ago. Now in this case, I don't know if they doubled or not, but I was told that they both grew by p%. And that's really significant. They both grew by the same percent, meaning they both got multiplied by the same factor. Well, as we discovered, if two different data points got multiplied by the same factor, the distance between them will also get multiplied by that same factor. So I have to keep that in mind as we go into these statements. Neither statement on its own could possibly be sufficient here, because with statement 1 we don't know anything about 98, and with statement 2 we don't know anything about 95. So certainly we can't find the value of p from neither statement on its own. But what if we combine them? If we combine them, we see that they're talking about the difference between the salaries. And we can see that that difference grew from 2,000 to 2,440. Now remember, whatever percentage the salaries grew by, the difference between the salaries would also grow by that percentage. So the growth, the percentage growth from 2,000 to 2,440 must be p. Now, since this is data sufficiency, you could stop there. We don't actually have to find the value of p. We can just say you could find the value of p if you wanted to, because we know p is the percent growth of that difference from 2,000 to 2,440. I think it's 22%. Right? I think 22% of 2,000 would be 440. Hopefully I'm not wrong there. But it doesn't matter for data sufficiency. We could find p. They are asking for p. Together these statements are sufficient. And the answer is C. So that concludes the official GMAT questions that I had prepared for us today. I'm going to, as I said, use the rest of the time to answer your questions. So please keep them coming. I did see a few earlier, so I'll address those first. I also would like to invite you all to subscribe to my YouTube channel, which is just youtube.com/quantreasoning. I upload a new video every day, and they're mostly my solutions, my reasoning-based solutions to official GMAT questions. So I invite you to subscribe if you haven't already, and of course visit quantreasoning.com to learn more about these approaches. So I did see a question about how much time do I take before I decide to use a number line or to not use a number line on a problem on the GMAT. There was a similar question earlier in the comments asking, do I bail on number line reasoning and switch to algebra if it didn't work? Or am I already at 2 minutes at that point and it's too late to switch method? I think those two questions are kind of similar. Here's the thing. Once you've practiced number line reasoning sufficiently, number line reasoning is very quick. I don't know if any of you noticed that in the questions that we went through today. But, I mean, those two data sufficiency questions, I think, can be solved in certainly under 30 seconds each, if you understand that concept that we talked about. That when you multiply data points by the same factor, the distances among the data points will also get multiplied by that same factor. Like if you understand that, they're very, very quick. Even the question with Q, R, S, and T on the number line, if you're proficient with number line reasoning, it really doesn't take more than a minute. Same goes for the a times a plus 2 equals 24. After you've done that a few times, it's very, very, very quick. So when I attempt a question with number line reasoning, I usually have already solved it. If I was going to solve it with number line reasoning, I already have the answer in, let's say, 20 to 45 seconds. It's very quick. Now, excuse me. Now, if a minute has gone by and I'm still not close to an answer with number line reasoning, well, then number line reasoning wasn't the right approach here. I can't say that that's happened to me, meaning if number line reasoning doesn't have a chance to get me to the answer, I'll know that ahead of time. So I don't imagine that that's a mistake that people will make on the test itself. Again, as I said earlier, when you're at home practicing, I do want you to try number line reasoning on every single question, because sometimes you'll discover new things that you hadn't thought of. But at the test center, there's a much greater risk that you wouldn't use a number line when you should have than the other way around. Does that make sense? I don't imagine that people would inappropriately use a number line reasoning approach when that doesn't work. I do imagine absolutely the other way around, where people didn't use number line reasoning when they should have. There was another question earlier about how do you identify when to use number line reasoning. So I'll say certainly anything to do with absolute value should be solved with number line reasoning. Certainly anything to do with inequalities, you should use number line reasoning. What are the other obvious ones? And I think those are the most obvious ones. A lot of algebra questions, even equations, right? That a times a plus 2 equals 24 was an equation. It wasn't an inequality, there was no absolute value, and yet number line reasoning was very effective. So again, the advice is try to think deeply about number lines in general as you're practicing at home. And over time, you'll gain experience and you'll figure out when to use it and when not to use it. Any other questions? JD, you had a question about P. Is it 440 divided by 2000 times 1000? Maybe you meant times 100. It should be times 100. So that should give you the answer. Was I wrong? Was it not 22%? Maybe it was 2.2%. Was it 2.2%? It might have been. I never really actually solved it for P because it's not necessary in data sufficiency. I have a question here about doing a future session about maximization and minimization problems. I could. The problem is that maximization and minimization is not that big on the GMAT. I don't know that I could do a full hour on it if I just want to use official GMAT questions, which I do because there's really no substitute for official GMAT questions. I find that when I try unofficial questions, number line reasoning doesn't work as much for me. It's almost like the GMAT questions are designed, the official GMAT questions are designed on purpose to benefit people who try to reason and punish people who don't. Maybe that's why they call it the quantitative reasoning section and not the math section. So I have a question here about how I would use number line reasoning to solve a question that involves absolute value. So let me pull up a whiteboard here and show you. So we have the absolute value of x minus 3. Is that greater or equal to x minus 3 without an absolute value? So is this true? Right? Is the absolute value of x minus 3 greater or equal to x minus 3. So the first thing we have to understand is that the left side here, the absolute value of x minus 3, that means how far from 0 x minus 3 is. Right? It's the distance from 0 of x minus 3. And they want to know whether or not that distance is at least x minus 3. Well, here's a number line. Here's 0. And we're talking about how far away from 0 x minus 3 is. Now, I don't know which side of 0 x minus 3 is, but I do know that x minus 3 is this far from 0, whichever side it is. So I don't know which of these is x minus 3, but it's one of them. And it's located x minus 3 away from 0. Is it equal to at least x minus 3? Well, let's see. Where is x minus 3? I don't know. So it depends. If x minus 3 is here, on the right side, what would you say? Is the absolute value of x minus 3 at least as big as x minus 3? If that's the one, that x minus 3? And what about this one? What if that one is x minus 3? Is the distance of x minus 3 from 0 at least as big as the value of x minus 3? Now, I don't think that this is that hard of a question, so you don't really need to draw the number line and think so deeply about it. You could instead just say, look, I don't know what x minus 3 is. If it's negative, of course it's yes. That's if x minus 3 is negative. And the reason I say of course it's yes is because the absolute value is not going to be negative. It's at least 0. So if x minus 3 is negative, then yes, something that's at least 0 will always be at least as big as something negative. And if it's not negative, if x minus 3 is positive or 0, well, in that case, x minus 3 is the same thing as x minus 3. So there as well, it will be at least as big as x minus 3. So the answer is yes either way. While we're on absolute values, let me just show you another, maybe a more complicated example. Say we're told that x minus 2 squared, oh sorry, that's too high. X minus 2 squared is greater or equal to 5. Okay? Actually, let's make it 25, so we won't have to deal with roots. The first step is to say, look, I don't know which side of 0 x minus 2 started, but I do know that it has to be at least 5 units away from 0. So that's how I would read this in English. X minus 2 is located at least 5 units away from 0. And just in case you didn't know, the reason I'm using an absolute value when I take the square root of both sides is because of that even exponent that hides the sign. It hides which side of 0 this all began. So now that I know that x minus 2 is located at least 5 units away from 0, I can draw that on a number line. And I can say that x minus 2 lives somewhere there or somewhere there. It's at least 5 units away from 0. It's like a restraining order, not allowed within 5 units of 0. But the question probably wasn't about x minus 2. The question was about x. So if I know where x minus 2 is, where would I find x? This takes us back to the very beginning of this hour. If you know where x minus 2 is, where would you find x? X would be 2 units to the right of x minus 2. So all we have to do is take these ranges that we drew and shift them 2 units to the right. And then we would say that x is at least 7 or x is no more than -3. So that's how you would use number line reasoning to solve this quadratic inequality. So I want to thank you all again for joining me here live today. I know that you always have the option to watch the recording, so I do appreciate that you kept me company here for the last hour and asked me great questions. I will one more time encourage you or invite you to check out quantreasoning.com and of course my YouTube channel, which is youtube.com/quantreasoning. Thank you all, and I hope to see you in another event in the near future. Thank you all. Thank you for joining me. JD and anyone else who didn't get an email from the website, please send me an email at info@quantreasoning.com. Again, that's info@quantreasoning.com, and I'll help you out. All right? You should have received an email if you signed up. So info@quantreasoning.com. Thank you.
Hey, Avi, this is Abhishek from GMAT Club.
And I'll help you out. All right? You should have received an email if you signed up. So info@quantreasoning.com. Thank you.
Abhijit from the GMAT Club.
Are we off the air? Abhijit, are we off the air? Hello?
Hey, Abhi, this is Abhijit from the GMAT Club.
Are we off the air?